Hello. Today I'd like to talk about factor polynomial. Now, what is the factor polynomials? Now, let's look at a very simple example. Like when we're going to multiply two numbers, 3 times 4, we know that is equal to 12. So the 3 and 4s, we call them factors. And then 12 is called a product. So from the left to right, so that is called a multiplication. But if you want to write a 12 in terms of the two or more than two number multiplications, like a 12 is the same as 3 times 4, and this is called factoring. So factoring a polynomial is the same idea. And deal with the number, now we're going to deal with some polynomial. As we know that like x minus 3 and multiply with the x and plus 2. Let's see this example. So we have the x minus 3 is one of the polynomial two-term binomial. There's another one. So this is multiplication. So what we can do is a Fourier, right? So x times x is x squares. X times 2, 2x. Negative 3 times x is negative 3x. Negative 3 times 2, so it's negative 6. Combine the like term, so we got x squares, negative 1x, and negative 6. So positive 2x, negative 3x is negative 1x. A different sign, we subtract the number, keep the sign of bigger one. Okay. So we got an x squared minus x minus 6. So those two polynomials, when they multiply them, it becomes this a higher order and more term polynomials here. So that is called a multiplication. Now, factoring a polynomial is mean you given a polynomial like this way. You want to write it as the 2 or more than 2 of a small degree or less amount of term of the polynomial multiplications. That is called a factor polynomial. It's an inverse processing of the multiplications. So as based on what we did last time, so we're gonna to be x minus 3 and multiply with the x plus 2. Of course, we got those two from the last example there. But without this one, without the last example in here, how are we able to figure out those two there? So that is the one we're going to talk about in this session here. So that is called factoring the polynomial. Okay, now I'm going to introduce some of the very common methods to do this kind of factoring polynomial. So the first step is going to see that is there any kind of common factor among these terms. If we do see the greatest common factor, we take it out. Right? So let's see the example. So for example, if we got something like a 3x squares, y squares, and minus 12x y3 and minus and 15x squared y3. Right? So for example, if they're given this kind of a polynomial, how can we factor that? So as I mentioned there, the first step, right, that is always we got to do that in generals. We're going to look for the greatest common factor among those three terms there. Now let's look at the numbers. First term has the 3, and then second one, negative 12 and negative 15. What is in common among those three numbers? Which is a 3. 3 can divide into all those three number layers. So we're going to take out the 3. Now, how about the letters? So the greatest common factors for the variable, for the letters, is the one with the smallest exponent. So x is the power 2, and this is the power 1, and then this is power 2. So x power 1 is the smallest one. So x to the power 1 is your greatest common factor for the x. And then same idea for the y. I have y squared, y3, and y3. So second power is the smallest among the 3. So the y squared is the greatest common factors. Right? So that is the one is called a greatest common factor for all the 3 terms. So I'm going to factor out. Now, after I factor out what is left over, I need to put inside the parentheses. So for the first terms, if you take out the 3xy squared, what is left over? So the leftover is for they are doing a division to get to the leftovers. So you're going to divide by the 3xy squared. So 3 is 1, x squared divided by x is x. So it's 1x. Y squared divided by y squared is 1. Not the y to power 1, just number 1. So you get a 1x. So just x. And do the same thing. Second one divided by 3x y squared. So negative 12, 3 is negative 4. X divided by x is gone, no x. Become number 1. Y3 divided by y2 is y to power 1, subtract the exponent. And then the last one divided by 3x y squared. So negative 15, 3 is negative 5. And then x squared x is x power 1. Y3 y squared, so it's a y. So we got this. So this original polynomial can become two polynomial. First one is just one term, and the second one is a 3 term. So become those two multiplications. The second one still has 3 terms, but it's less powers, less degree. Right? So that is called a factor of the greatest common factors. Now, after you take it out, is there anything we can continue? So for this example, we cannot continue for the whatever leftovers inside this. Right? But for some others, we may able to continue there. Right? So let's look at another method, which is considered second step. The second step we're going to do that is based on there's many of the case there. So I'm going to base on the number of the terms. If the after take out the GCF, if the leftovers, the one inside the parenthesis, if there's 2 terms, so we have some way to do that. If there's 3 terms, we have another way to do that. If there's 4 terms, we have some other way to do that. Right? So let's look at it. If there's 2 terms, so if there are 2 terms, has a few of the case. Right? Of course, there's more than that, but when there are more degree of that, it's getting more complicated. So we only deal with those 3. That's the most common. So first one called a difference of the 2 squared. So it's like a squared minus b squared. So that one can be factored, become a minus b times a plus b. So that is called a difference of the 2 squared. So when you have 2 terms, both are perfect square, and there are subtraction between them. Remember, it's not an addition, it's a subtraction between the 2 perfect square. So you can always able to factor become a subtraction times addition of that. It doesn't matter subtraction go first or addition go first. Right? So let's see the example here. For example, if we got an x squared minus 25. So x squared is a perfect square. 25 is also being a perfect square, is 5 squared. So that is a x is 8 and 5 is a b. So that become x minus 5 times x plus 5. Of course, we can write an x plus 5 first. It doesn't matter. Right? So that is using the formula we have here called the difference of the two perfect squares. Now we can get to some more complicated example. Let's see that as a 4x squares minus 9y squares. So it's the same thing. 4x squared is a perfect squares. It's a 2x times 2x. So a is in a 2x. And 9y squared is a 3y times 3y. So the b is a 3y. So that become 2x minus 3y. And then 2x plus 3y. Okay. Now, besides for the difference of the two squares, we also have the difference of the two cube and sum of the two cube, those two. But this is getting a little bit more complicated, and the formula is a little bit longer. So I'm not going to talk about in these sessions here. Right? Okay. Now let's deal with the two terms. Now let's see that as about three terms. Right? Now 3 terms is something we call the trinomials, and the one we're going to talk about is a quadratic trinomial, which is like a x squares and minus x minus 6. Right? Or it could be could be using different letter. It doesn't matter x, y, or a or b. Y squares minus ay and plus 15. Right? So it could be something like that. That is called 3 terms. And then the higher exponent x squared or y squared has the coefficient of the 1, which means there's no number in front of that. So that's the one we call the leading coefficient is equal to 1. When the leading coefficient equal to 1, so there's an easy way to do that. When the leading coefficient is not 1, we're going to have a complicated way to figure out. So we're going to talk about this first. So let's using those two examples. Right? Now, how we're going to factor that? All this kind of the trinomial, quadratic trinomial. Quadratic is mean the exponent, the higher exponent is a 2. Right? This kind of the polynomial is always able to factor into the 2 binomial multiplications. And 2 binomial multiplications. So this one is always able to make it become x and plus or minus something multiplied with the x plus or minus something. So we need to figure out those two numbers. Now in here, those two numbers has a certain property on it. When those two numbers multiply, it will get to a constant term, which is -6. When they add them up, it comes out a middle term here, which is -1. So what is those two numbers? So we can try, guess, and try, guess, and try, right? So there's a way to do that. But I want to do a little bit formal way, do not missing any kind of combination. So you take out this -6, you're going to write down the all factor about the 6 there. So 6 could be what? 1 times 6 is 6, and could be 2 times 3. That's it. No any other case. Now, if this is negative, it means we like to have the subtraction to get to the middle term, which is -1 or 1, right? So the subtraction to get a -1 here is this one, is 2 and 3. So those two numbers will be 2 and 3. And then the bigger numbers, 3 here, is always has the same sign as in the middle term here. So the middle term is negative, so 3 will be negative. And then when I multiply that, it's -6. So -3 should be multiplied with +2 in order to get a -6. So the answer for it is x plus 2 times x minus 3. So if you're going to Fourier, then you're going to get a 2x and -3x, which is -1x. -3 times 2 is -6. And x times x is x squared. So you can Fourier then to check the answers right or not. So it's the same ideas. So in here, this is +15. So you break it down all the factor of the 15. 15 could be 1 times 15. And 3 times 5. And 4, that's it. And then we like to get an 8 in the middle. Okay. So when we add them up, we need to get an 8. And then if this is an addition, this is plus sign, it means you're going to do the addition to get the middle term 8. So this should be the 3 and 5 is the number we're going to choose. So that will be y and 3. And then the second one will be the y and 5. Which one go first, it doesn't matter. Okay? And then the bigger number must have the same sign as the middle term -8. So 5 must be negative. When we multiply them, it's equal to +15. So 3 must be negative. Negative times negative is equal to the +15. Okay. So that is how we're going to factor a polynomial with a leading coefficient not equal to 1. The leading coefficient is equal to 1. Okay. Now, for the leading coefficient not equal to 1, let's see this kind of the case here. Right? So there's some number in front of that. So for example, it's like a 3x squared, and then minus 4x. And then minus 4. Okay. So for example, like this one. Okay. So the number in front of that is 3 in front of the x squared. So the leading coefficient is 3, not the 1. Okay. So I will talk about this one later. I need to talk about this 4 term first, and then come back to talk about this one. Okay. Now, if there's 4 terms, we're going to use something called a grouping methods. Okay. So grouping method, let's talk about the grouping method first. Right? So for example, like x3 minus 2x squared, and then plus 5x minus 10. So what we're going to do is going to make it as a 2 group. Most of the time will be a 2 term as a 1 group, right? So for example, I'm going to make the first 2 as a 1 group and last 2 as a 1 group. Right? So I'm using a parenthesis to enclose that. So I key that this is an additional sign between them. Okay? And then I'm going to factor each one to take out the greatest common factor for each group. So for example, for the x3 minus 2x, for the number has no common factor, but for the letter x, the x squared is a common factor. The smallest exponent one is the GCF, so it's the x squared. So if I take out the x squared, so x3 divided by x squared is x. Negative 2x squared divided by x squared is -2 times -2. Okay. And then keep bring down this is additional sign. And then 5x and -10. So what is in common? Is the 5. 5 can go into the both numbers. So take out the 5. And then first one is the x, second one is no x. So x is not in common, just 5. So if I'm going to take out the 5, 5x divided by 5 is x. And negative 10 divided by 5 is negative 2. And then we're going to look at the two group layers. That both group has what? X minus 2. So which means x minus 2 is in common. So I'm going to take it out. So if I take out the x minus 2, so what will be leftovers? Right? So if I'm going to divide by x minus 2 or take out the x minus 2, so for the first group, is x squared leftovers. And for the second group, is positive 5 leftover. So we're gonna x minus 2 times x squared plus 5. Right? So that is the method called a grouping method. So make it as a two group, and then for each group, we take on the greatest common factors. Then we will see that, and both group has something in common. You're going to take out x minus 2 is common. Once you take out this x minus 2, first group has an x squared leftovers, and the second group has a positive 5 leftover. So x squared plus 5 is the second factors. So this polynomial 4 terms can factor become x minus 2, x squared plus 5, those two. Okay, so that is the grouping methods. Then may deal with some of the different meaning of the different letter layers. Let's see another example on that, like a 3xy minus 6xt and minus 2ys and then plus 4yt. So let's see this example. So same idea, I'm going to make it as a two group. So first two as a one group, 3x, I'm going to rewrite it. I'm using a parenthesis to denote it as the first group. And then the second one, I bring down the subtraction, and then I put a parenthesis. But you got to be careful in here. When you have the, when you bring in into the parenthesis, or from the parenthesis bring in out, the sign of the term must be different. So negative 2ys must become positive 2yx. And then positive 4yt must become negative 4yt. The sign must be different. If you're going to remove this parenthesis, so negative 2 and negative 4 become positive 4, you got to change in the sign. You will get back to the above. Positive 2 become negative 2, and negative 4 become positive 4. So you will get back to that. So you got to be careful as there's this negative sign in front of the parenthesis. The sign you have inside the parenthesis must be different with the sign without the parenthesis. Okay, now let's look at the first group that both has the common 3 and then both has an x. So the 3x in common. So if you take on the 3x, so the first group, first term has the y left, and then 6xt take on the 3x, 6 divided by 3 is 2, so it's 2t. And then for the second group, oh sorry, my fault. The example is not. This one should be st. Sorry, I did not make a good example here. This should be st. Okay. Now bring down the negative sign for the second group. So 2 and 4, and 2 is in common, and then both has an s. So s is in common, take it out. And then if you take on the 2s from the first 2ys, so y is leftovers. If you take on the 2s from the second one, so negative 4 divided by 2, So it's the -2 and then t leftovers. Okay. Then we will see that both group has the y minus 2t. So y minus 2t is the one in common. So if you're going to take out y minus 2t from the both group, and then what will be left over? So for the first group, if you take out this one, so you have 3x leftovers. For the second group here, if you take on the y minus 2t, so it's negative 2s leftovers. So the factor of this polynomial, it will become these two factors, y minus 2t and 3x minus 2s. So that is how we do a grouping method to factors anything 4 terms. Okay. Now let's talk about it in the trinomial with the leading coefficient not equal to 1. So that will be a little complicated case. We need to combine the last two methods we talk about there. One is the leading coefficient equal to 1. One is this grouping method together. Okay. So let me make examples. Right. Let me think about the example. Must make right numbers. Right. So I think the example I said out earlier, 3x squared, right, and then minus 4x, and then minus 4, that one. Yeah. Okay. So what we're going to do is, it cannot just using this constant number -4 to break it down, making two binomial like that way. Right? So the idea is I'm going to break it down, the middle term become two terms. So -4x could be -2x and -2x, could be -5x, +1x, could be many of the combinations, but there's one of the combination may allow us to continue factoring using a grouping method there. Now we need to figure out those two numbers. So how are we going to figure out? We got to multiply the leading coefficients with the constant numbers, right? So we do the multiplications. So 3 times -4 is -12. Then we're going to break it down a -12, or we're going to write down all factor of the 12. So it could be 1 times 12, and could be 2 times 6, could be 3 times 4. That's it, 3 pairs. Now, one of the pair we're going to use to get to the -4, and this is a -12, so it means to get a subtraction to get a middle term, which is -4. So the one we're going to have is the 2 and 6. And then the bigger number must have the same sign, so the 6 will be negative, and then 2 will be positive. So in order to get a -4, when we add them up and multiply them, is -12. So -4x can break it down, become +2x and -6x. Now, which one you want to write first, it doesn't matter. I prefer to write a positive one and the second part later. So will be a -6x and +2x. If you want to write a -6x on the second one, is also okay, because as we mentioned before in left here, when this is a negative sign, we got to change the sign in the second parenthesis. That is only the one in theirs. If this is the positive, you don't need to change anything in the second parenthesis. Okay? So that's why I prefer to put a positive there. If both are negative, so it doesn't matter. Right? And then bring down the rest of the terms, -4 and 3x squared. Then you're going to group it. First two as one group, and the last two as one group. You can see that this is a positive, so I don't need to change anything on the second parenthesis. If this is negative, I got to change the sign, right? So that's the reason I prefer to using a positive on the second one. But if you're using a negative, you will get to the, if you switch in the order, you will get to the same answer in the end. Now for the first group, and 3 and 6 are 3 is in common, and both has x, so x is in common. So take out 3x. So 3x squared, take out 3x is x. And negative 6x, take out 3x is negative 2. When you take it out, you got to divide it. Right? And then bring down the additional sign. And then 2x and negative 4, they both can divisible by 2. So take out 2. So 2x take out 2 is x. Negative 4 take out 2 is negative 2. Now we will see that in both group, that both has an x minus 2. So x minus 2 is in common. We take it out. And then once we take it out, in the first group, this x minus 2 is gone. So the 3x there. For the second group, the x minus 2 is gone. So it's only positive 2 left. So 3x squared minus 4x minus 4 can be factored become x minus 2 times 3x plus 2. So become 2 factors, and both are first powers. So that is how we're going to factor 3 terms and the leading coefficient not equal to 1. So it's a little complicated, right? So those are the methods we talk about here. Right? So those are very common and basic methods to factor the polynomials for the 2-term, 3-term, 4 terms, and so on. Right? Now, of course, someone may have a better way, right? So you can leave a comment for me. Right? Okay, this is what we're going to talk about today. Thank you.